Okay, well, we're gonna I think that's like the next couple of slides, so we'll just go ahead and, which I skipped this one anyway. And they also start calling the point estimate. So I'm just letting you know that sometimes they call remember, I still think that a lot of people take statistics because they can't finish mathematics. So anyway, that's all I'm gonna say. They make up stuff. Did I hit record? I am recording. Okay. And we went over p-hat and all that good stuff. So I'm just going to make sure everybody understands what we went over so far. There's p-hat again. P-hat and q-hat. Make sure you know that. N is always your biggest what? Your biggest number. And we talked about this, blah, blah, blah. Put n, x over n. There's your p-hat. So q-hat would be 0.37. Bless you. No more sneezing. And then I told you to do a card. Okay, we're going to do that here in just a second. Okay? Good gracious, you allergic to somebody? Maybe. All right, so here, and there is the confidence interval. So go ahead and write down. I think that's where we left off. The confidence interval is point estimate, which is p-hat, plus or minus the margin of error. So if you write down the interval, the confidence interval, it's going to look something like this. And I'm just going to make up a number. And this thing's going to... Maybe one day when I get training on this thing, I'll figure out what that is. Let's say 0.48 and 0.52. Now, you could say 48% to 52%. Everybody got that? Now, if I give you 0.48% or 48% to 52%, what does that tell you about the margin of error? It tells you that's 0.02, right? 2%. Then what is p-hat? That's what I heard. Articulate and volume. What is p-hat if the margin of error is 0.02? 0.5. Good job. So there you can find two things from the what I just call that confidence interval. What can you find? You can find the margin of error, and you can find p-hat just by looking at it. So write that down. You can find the margin of error, and you can find p-hat. Margin of error is referred to as MOE. After this day, when I put MOE, I don't want you saying, what does that mean? 2, you can find p-hat. Margin of error is going to be your midpoint. What's your midpoint? You take the lower plus the highest and divide by what? 2. So 0.48 plus 0.52 divided by 2. And that's going to be 1.00 divided by 2, which is equal to 0.5. So p-hat, or did I? Yeah, p-hat. I'm sorry. P-hat. Now, once you've found 0.5 is p-hat, which is your midpoint, then you say, well, how much is the difference between 0.5 and 0.52? Or 48 cents and 50 cents? What's the difference? 2 what? 2 cents. So you know if you take 0.52 minus 0.5 or 0.5 minus 0.48, you're both going to get 0.02, which is equal to the what? Margin of error. So that's how you find the margin of error and the p-hat when you're just given the confidence interval. Because there is a question on the test, and standardized test questions, that all they give you is an interval, and they say, what is p-hat? Or they're going to say, what is the margin of error? And you'd be surprised how many people sit there and stare at it for 15 minutes, and then they just skip it, or they guess. All you have to do is a little bit of subtraction and a little bit of addition. and division, sorry, go with the midpoint. Or you could just look at it and say, well, the difference between these two is 4 cents. The difference between 48 cents and 52 cents, 4 cents. Half of 4 cents, 2 cents, so that's the margin of error. And then you subtract 2 cents from 52 cents, you get 50 cents. So that's a little bit of what the margin, the confidence interval can give you. Again, the standard deviation is P hat Q hat divided by N. And we already went over a little bit of this. And N is, lowercase n is always going to be less than or equal to 5% of big N. Everybody understand? Some people are just not that smart. Lower bound, upper bound. Write this down. There is your, just forget this right here. I don't like the way they got this. I just want you to write down this right here. Okay? That is your margin of error. Margin of error is your z-score, so alpha over 2 times p hat q hat over n square root. Now, just chill a minute and I'll show you why I erased the whatever that was, p. I'll get to that in just a minute. Okay? So I just want you to learn the formula. Z sub alpha over 2. So that means I've got to find a z-score at alpha over 2. Now let's focus on this. Take your handy dandy highlighter. And we need to focus on that guy. Remember me telling you about the index card? And you need to fill out the index card. We're going to do that here in just a minute. So I need you to get your calculators out because we've got to do the z-scores. Okay? And I'm going to fill out that card for you for the 5 or 6 people that actually do it. Okay? So let's take it to a whiteboard. I need to get out of this. And P hat Q hat over N, remember that. And let's go to the whiteboard. So we're going to have a BA part. And this is what I tell all my 120 students, all of them. So night class also. Here, I call this confidence level. This is alpha. This is alpha over 2. And of course, this is z sub alpha over 2. So that's your titles. Now, also, the z is going to be the absolute value. Okay? No negatives, just absolute value. Now, as I told you, we're going to go from 90, 91, 92, 93, 94, 95, 96, 97, 98, 99. Now, I'm not going to do all of them, okay? I'm going to do the first one, the middle one, and the last one. And you fill out the rest of them. So, if the confidence level is 90, what is the complement? CL complement. What's the complement of 90%? Good job. And there's arbitrary. I think the Russians. Yeah, I can. Democrats say there's still evidence. I think they lost their damn mind.
I thought they were just going to try that out.
Not to. You gotta realize how much hate there is. When you can't. I'm gonna give you an example. Some of you girls can relate to this. when you have a ex-boyfriend that don't know the meaning of the word go away, you know what I'm talking about? Oh my gosh. Okay, I need...
Aren't there like $4 billion into this investigation?
No, 25 million. 25 million, yeah. And their boy, Mueller, says that there's nothing there. So the Democrats say, well, we want to hold court so we can find something. Take this downstairs, ask one or two of those, please. Tell them I see that you please. Okay. So what is the, I'll use my finger for right now. What's the complement of 95%? And what's the complement of 99%? Okay, now I want you to fill that column out. That should not be hard. Okay, just think of it as cents. What's the complement of 91 cents? 9 cents, Hubert. What's the complement of 92 cents? 8 cents, Hubert. Wait a minute, I have to do that. So, do the third column. So what is 10 cents divided by 2? 5 cents. 0.5. And then do the third column. Now, why do you need to make this index card? So on the test, you're not having to what? Do it on your calculator. Does it save you time? Yes. For the 4 or 5 people that actually are going to do it. Now, what do you do with Z? Well, now you look up inverse norm. Let's see, for 0.25. And what's half of 1 cent? 0.005. Right? All right, so take your inverse norm. Wait a minute. No. Yeah. Inverse norm and write, make sure all these are in 4 digits so you remember. See what happens when you don't put the area in 4 digits, you forget. I should have put it in 4 digits. Put those in 4 digits. No, that's your block, that's your area. Okay? Put in inverse norm, 0.0500. Somebody tell me the absolute value, so don't give me no negative. Okay? So what is the z-score that goes with 0.0500? 1.64 even. Okay? And now somebody do inverse norm for 0.0250. They give you any flack?
It's just flushing air to get you battery.
Oh my God. Well, the IT department would check these and, oh yeah, that means they would have to actually do their job.
You're probably going to
What?
probably get a bill in the mail.
Yeah, probably. But it'll get better when everybody has free college. How many of you know what a gas can is? Okay, what did a gas can used to be like? Gas can was red, had a top and a spout. Have you ever seen one new? Have you bought one new lately? Go out and try to buy one. But buy one first, it's like $10, $15. Have you ever tried to operate a new gas can? Don't. Take the top off of it and do what with it? Throw it away because you can't work it. The federal government took a gas can that was real easy to use and they made it into something that you can't use. Go try to use one.
What's
they put these triggers on it so that you can't, if you drop it, it'll quit, it won't spill gas out. But you got to hold one thing, and then you got to mash this down, and then you can pour it. I just take it off and take the old one off my old gas can and put it on. If you have no idea what I'm talking about, you think I'm crazy, but try to use one. Go try to use one. That's what happens when the federal government
the ones
gets
that you
involved.
have they can screw down the end of the can, pull it out, and put the seal back on, and then put the faucet back on?
Those are the old ones.
I don't like those.
Well, go try a new one.
The ones you have to screw on and all that.
I take milk jugs because you know why? They're what? They're simple. All right. Somebody did inverse norm 0.0250. What do you get? Somebody should have already done it. I mean, it's up here on the board. 0.0250.
196.
1.96. And somebody do 0.0050.
2.58.
I'm sorry, what?
2.58.
All right, now fill in the rest. This would be 0.09. Told y'all we're going to do this. This would be 0.08, 0.07, 0.06, 0.04, 0.03, 0.02. And this would be 0.0450. This would be 0.0400. 0.0350. Wait a minute, I got something wrong. Oh, 0.03. I was thinking of another number. Okay, this would be 0.0200, and this would be 0.0. No, that'd be point. That goes with that, and that's what happens when you don't have lines. And 0.0100. And this thing is just going freaking crazy. All right. So has anybody done any of these? We'll go ahead and fill it out for those people that are just plumb T lazy. What's inverse norm of 0.0450? 1.69. How about 0.10400?
1.75.
Guess I'll rely on one person. 0.0350. Thank you. 1.81. 0.0300. 1.88. 0.0200. 0.0150. And the last one, I can't even read it, 0.0100, 2.50, 0.0050, I guess it starts to level out. Those last two, I didn't know they were the same. 0.0100, yes.
But I didn't my calculator, I gave him a negative. Is that right?
Yeah, I said the absolute value right here. It's always the what? Absolute value. Make sure you make a note of that because I'd hate for you to put in a negative. Okay? Now, you take that card, and whenever you need to find the margin of error now, if you want to find a 95% confidence level, the z sub alpha 0 is going to be, or alpha over 2 will be 1.96. Get it? Simple as that. Now, on your homework, you might be given 83%. Now, of course, 83% you would not even take into a meeting. But for homework purposes, so you don't get these same numbers over and over, the computer regenerates and will give you something like 83%. So let's do one of those. 83%, what is alpha? What's half the set? Let's make it 84, please. 84 would be 0.16. What's half of 16 cents? 0.08, and somebody do inverse norm of 0.0800. What do you get? 1.4 what?
0.
Okay, so there will be some homework questions that'll just give you something like this. find z sub alpha over 2, and they'll put, they'll say at a 75% confidence level. And they'll put CL right here. Oops, not LC, CL. So in that case, let's make it 76. So that would be 24%, and half of 24 is what? 12.1200, so you would do inverse norm 0.1200. And that would be your z-score at a 76% confidence level. Okay, so everybody got the method there to find your z sub alpha over 2? Okay, now it's going to ask us to find the margin of error. So now we can go back and do that. So that's why, see, that's why I don't like when they put this before what? That. I don't like that slide. So there is your margin of error. All right, write that down. Same one we had before, and they want a 90% confidence level. I'm sorry. They want a 90% confidence interval based on a 90% confidence level. I don't like the way they got that. Okay? So they want the confidence interval based on a 90% confidence level. I want y'all to do it. Now that you got the formula, now that you know how to do it, you should be able to plug and chug. If you can't do it, just write it up as a failure in life.
For the z-score, did we have 1.645 or 1.65?
I'm sorry, I'm off the clock right now. I think it was 1.64. I asked somebody if it was 1.64 even, and nobody said a word.
There's just 5 of them.
Oh, okay. Yeah. I appreciate it. 10 minutes later.
I was giving you batteries.
Yeah, that's right. You could put 1.645 if you want to. It probably won't make that much of a difference, but if you do a 90% confidence level and you come up a little bit short, then you might want to change it to 1.65 instead of 1.645. You see what I'm saying? Or you could just quit altogether. Quitting is what? Easy. So first of all, you got to find what? P hat. So P hat is equal to, and I know we've done this before, but what I'm saying is when you're given a question and they're asking for a confidence interval, you're going to have P hat somewhere because you got to find the margin of error. And if you have to find P hat, that means you have to find what? Q hat. So P hat is equal to 1123 over 1783, which is equal to, somebody give me 2 digits, please. Is it 0.63 or something like that?
I got 0.68.
68.
Oh, 0.63, I'm sorry.
63. So therefore, Q hat is equal to 0.37. So I'm going to take my handy dandy green highlighter and I'm going to highlight, well, those are very important. Now at the next junction, because I know we're going to ask for the margin of error or the confidence interval, I'm going to do all of it. Next thing I'm going to do, I've got to find 90% confidence level. 90% confidence level. I don't know where that LD comes from. I guess I'm just dyslexic this morning. Saw the drinking. I don't even know where the green pen came from. I guess I'll just keep writing in green. 90% confidence level gives us alpha equals 0.10 and alpha over 2 is equal to 0.05. So what is my alpha z sub alpha 2 or whatever? What does it come out to be? Look on your card at a 90% confidence level.
1.64.
I'm sorry, what?
1.64.
Thank you. I'm going to use 1.65. And we'll see what they use when the slide, probably 1.65, because usually z-scores are rounded to how many decimal points? 2. So since it's 1.645, I would say 1.65. All right, now, we've got everything we need. We know that our formula says MOE is equal to your z-score, which is 1.645, or 65, sorry, times the square root of p hat times q hat over what? N, which is what? 1783? And I need somebody to crank all that out. Now, you don't have to tell me the answer right now, but let me ask you a question. In probability and statistics, when you're in a presentation mode or a presenter mode, presentee mode, in other words, if you're sitting in a meeting or if you're given a meeting, what is your number one goal? To be very what? Accurate, right? So if your accuracy is between 90 and 95, 99%, then what is your margin of error usually going to do in relation to your confidence level? If your confidence level is way high, what should your margin of error be? Real low. If your confidence level is real low, your margin of error is going to be what? An acceptable margin of error is 1 to 3% in statistics. All right? So if you're talking national polls, you look down at the bottom. Do they show it in big print or very fine print? Very fine print, because sometimes they're trying to make you believe something in polls. Sometimes. If you get a poll and it says 8%, it ain't worth the paper it's written on. If you get a poll that says 1% or 2% or 3%, then you can take it for what it really is. Okay? Anything above 3%, I wouldn't even look at. What does this come out to be? Give me 2 digits. Or 2 decimal points.
0.0186.
I couldn't hear you.
0.0186.
0.18 would be 2.02, right? So that's a 2% margin of error. 90%? 2%, yes. What if you did a 90% confidence level and you came out with 17% margin of error? Something is what? Wrong. And that's, again, you're not in here to learn how to be a statistician. You're in here to do 3 things. Be a presenter, be a presentee, or take other classes later on with this stuff, okay? So if you're looking through a magazine, or you're watching the news, and, you see a 17% margin of error, you know something's wrong. Now, that's it. What about P hat is what? What was P hat? 0.63? So P hat What's 63 cents plus 2 cents? So that's the upper side. And what is 63 cents minus 2 cents? And this is what we call the confidence what? Confidence interval. This is a test question. Write this down, mark it, because if I give you any tests on what we've done so far, this is a test question. So hopefully I'll fill up the test with these questions and everybody will make an A. Okay? Now let's see what they got. Because it could be a little bit off, they could have used 1.645. I don't know. I probably think they used 1.65, but let's see. They used 1.645, and did they get the same thing? Yep. So the 0.005 is really not going to throw it off that far. Okay? Now, what did they do right here? They checked to see if this is correct. Okay? It says NPQ. Write that down. If NPQ is greater than 10, remember 10 is that number that they use, okay? It's got to be greater than 10. Then you can do this operation with, and it's also, and the sample size is definitely less than 5% of the population. Well, what's 10% of the population? What was N? Somebody look, what was N? I'm sorry, 1783? So 10% would be 178, half of 178, half of 180 is what? 90. So 90 is greater than what? Is 5% of the population. That's yes. So you can do this problem, which they very rarely give you a problem you can't do. All right? So they should set it up. There it is. The confidence interval is what? Between 61 and 65%. Now, what is that saying? It's saying that we, as a presenter, we, as a statistician, are 90% confident that the death penalty for those convicted is between 61 and 65%. Now, what have I said? We are 43% confident. Right then, everybody, the population of the audience would what? At 43% confident. Psh, shut down. Why? Because I'm not going to spend time listening to somebody that's presenting something that's only 43% confident. You with me? So that's why you like to stay between 90 and 99%. Don't walk into a meeting with a 43% confidence level, please. You might get fired. All right? There is our last formula for 9.1. Write it down. Now, the way I would write it is this. I don't write it like this book, because this book, sometimes I don't agree with this book. So I'd write it like Triola. N is equal to P hat, Q hat, times Z over E squared. Okay? Because everything in this unit, in chapter 9, is Z sub alpha over 2. Okay? That index point. So you can write it either way. It's up to you. And of course, this is a test question. I like to give you a lot of 9.1s on this test because, like I said, this is probably the most aggravating unit or section or unit, because after today, after 9.1, it starts to get a little bit confusing, okay, to some people. Well, okay, always round up to the next integer. I don't care what you get, because there's no such thing as 0.2 people. How many people do we need to survey? How many people do we need to ask? How many people do we need to blah, blah, blah? People do not come in decimals. So if I get 12.5 people, that's automatically 13. If I get 132.2, that's automatically 133. You always round up. Kind of like an engineer's thinking. You always overcompensate. You always, when you're putting in a measurement or the tensile strength of a 6-inch I-beam is 450 pounds, I'm not going to put it exactly at 450 pounds. I'm going to say 500. I'm going to figure in 500 because you never know when somebody's going to be over 450 pounds on that I-beam. Okay? So that's why you want to up it to 500. You always go up. Y'all settle down. I know this is exciting stuff. If there is no P, write that down. It's assumed, why? Why is it assumed to be 0.25? What's the square root? Well, if you multiply 0.5 times 0.5, P times Q, if you don't know it, you assume it's yes or no. What's 0.5 times 0.5? 0.25. That's why. They're assuming if there's nothing given for P, if nothing is given, then you assume it's yes or no. It's 0.5 and 0.5, which is 0.25. And now it's probably going to give you an example. There we go. A sociologist wants to determine the percentage of residents of America that only speak English at home. What else would you speak outside of the house? I don't understand that question. Think about it. A sociologist wanted to determine the percentage of residents that only speak English at home. If I was not from America, I would speak my native language at home, wouldn't you? And if you're from America, what are you going to speak all the time? English. So I don't understand the question. But anyway, what size sample should be obtained if she wishes her estimate to be within what? 3%. So margin of error is what? 3. With a 90% confidence level. So you're going to use what? 1.645 again for Z. Obtained from the census supplemental of 82.4%. So what is P hat? 0.8240 or 0.824. So Q hat's going to be 0.176. And you plug and chug. Now notice, what did they say? I said that margin of error was 3%. Did I type it in as 3% or did I type it in as a decimal? As a decimal. You need to make a note of that because that's what you'll mess up on the test. So let's highlight that in green. That's the number one mistake students make on the test. They won't type in, they'll type in 3 because the question said 3%. Margin of error, 3 percentage points, and the students type in 3. You don't type in 3, you type in 0.03. So, you got 436.04. Is there such thing as 0.04 people? No. So, you raise it up to 430. So, she's got, now, if I was her, would I stop at 430 or would I do 500? 500. I would survey 500 people. Remember, the more you put into it, the more what? You're going to get out of it. The better your data is going to be. So if you want to be lazy, then do 437. But I would, if I was getting paid to present or I was getting paid to do quality assurance for somebody and I had to survey so many employees, buddy, I would survey at least 500. If this question, if I wanted to be 90%. Of course, if you went to 95%, then that would go from 437 probably up to what? Probably up to 1,000. Somebody put 95% in that same problem. So in other words, change your Z-score to what? What's 95%? I'm sorry, what? What's the Z-score for 95%?
1.96.
I didn't hear you.
1.96.
So change that to 1.96 and tell me what you get. Of course, 3% margin of error would go up to 2%, go down to 2% probably. But we're just going to see what changes. What does it change it to? As soon as you get your number, just spit it out. It's going to be more than 437. I'm sorry, what?
622.
So if you change just one thing to a 95% confidence level, it changes it to what?
622.5.
622. I would probably go to 650 if I was going to put out a survey or a questionnaire or whatever the case may be. So you get the point. A 95% confidence level would up your population that you're going to survey to 650 if you wanted to make sure, but the answer would be 622 based on a 95% confidence level. Okay? So in 9.1, you should be able to find four things. You should be able to find P hat, you should be able to find Q hat, you should be able to find your margin of error and your confidence interval, and you should be able to find your population size, which is E. Okay? Question, right, complaint. And we'll worry more about this later. All right, I'm going to call the roll, and y'all can leave for today.